You are listening to the Wi-Fi Ninjas podcast, where we talk about wireless technology. Here are your hosts, Mac Daring and Matt Starling.
Hey everyone, and welcome to the latest episode of the Wi-Fi Ninjas podcast. Matt and Mac are here, but we're also joined with our friend Özgür from Litum. Would you like to introduce yourself, please, Özgür?
Yes, hi, my name is Özgür, and I'm one of the co-founders of Litum, and I'm also responsible of our global sales network.
Thank you very much. And how are you, Mac?
As always, I'm extremely good. Thank you very much. And thank you very much, Özgür, for joining. Thank you very much, Litum guys, for being here with us, for donating your time to discuss RFID with us today. So for us in the Wi-Fi community, RFID is something mysterious, okay? We haven't seen any good materials about RFID, good use cases for the RFID that are combined with the usage of Wi-Fi. So we are very passionate about RTLS, as not only the Wi-Fi Ninjas, but the community is picking up very quickly, and we are dying to understand how RTLS operates really. And we know that you have a good history with RTLS. This is not your only focus now. You focus on different technologies like ultra-wideband as well, but at the core, long time ago, you were focusing more on RFID, I believe. So would you please give us some more insight into the history of Litum? How did it start, and what did you use back in the day, and what are you using today?
Sure, absolutely. Thanks for having me on this session. It's very good to talk with you guys. Litum was established back in 2004, 16 years ago. 16 years ago, passive RFID, especially the ultra-high frequency UHF passive RFID, was just coming out of academic research phase. So it came out of MIT's Auto ID lab, and Walmart was the first company that wanted to use this in their global distribution network. When we first researched the market, when we first started the company, we saw that there was really good potential with passive RFID. You could utilize passive RFID on many different use cases and many different applications. So that's how we decided to dedicate the company's core expertise area on passive RFID. But as I said, I mean, it was brand new, no experience, no knowledge, very limited supply, very limited technology globally wherever you look, and it was also very expensive. So it was very challenging in the back in the day to deploy this technology massively to large customers. So when Litum first started operation in 2004, it took us about 1.5 years to really understand the technology, test it on our own, implement test use cases, demos, and things that we can show to customers. So when we reached 2006, we were having more serious dialogues with our customers about the technology, but still it was too expensive. I mean, a cost per tag back then was around $1.2 per unit. And you need to deploy millions of these tags to have the system operational and functional. And now the unit cost of a tag has dropped down to 5-6 cents. So imagine that big price decrease over the years. Again, back in 2006, there were a very limited number of use cases that we were able to put this technology in. But it happened slowly. When we made it to 2008, we had some customers using our solution. And it was mainly for supply chain and logistics types of applications like warehouse management, process improvement, and then asset management applications also picked up. So we were quickly building a lot of different solutions. Initially, when we first started Litum, our idea was to focus more on the manufacturing side, manufacturing including its supply chain and operations. But as we learned the technology, as we spoke with more and more customers, we then saw where this technology can go to. It can go anywhere. It's in our lives. We tell our customers the limit is is based on our imagination. The more you imagine, the more you can do technological solutions for your customers. Our company started out in Turkey, but it stayed in Turkey for a very small amount of time. I mean, maybe for the first 3-4 years, we focused on our local market, but immediately after that, we became international, global. So we quickly spread around in Europe, in the Middle East, and now we operate in almost 40 countries worldwide, all over the world. You can see our solutions in the North American region, in South America, Asia Pacific as well. So it's been a good journey overall within the last 16 years. Technology has matured significantly. So back when I compare the past 16 years and now, today it's like a commodity. You can see passive RFID in different areas, in different use cases, hundreds of manufacturers out there manufacturing different types of components. That makes the overall application a lot more stronger. So that's where the technology has come to now. Today, the deployments are not pilots, are not POCs, but they're global rollouts, large-scale projects. So there's been a lot of traction since we first began using this technology.
Okay, so you have mentioned several very interesting bits there. First, it was that the tag was expensive at $1.2. It really sounds very expensive, especially when compared to ultra-wideband tags and BLE tags and all the other tags. And now they're 5-6 cents. So you're talking about the passive, very small little printed tags that they have.
Correct. That's correct.
It's just like an antenna with some very, very not complicated design that doesn't have active components.
That is correct, yes.
And you are using passive RFID versus active RFID. Is there still an application in the market for the active RFID, or is it mostly passive now?
No, so it's a combination. Active RFID is also really interesting. We are providing a lot of ultra-wideband based RTLS or active RFID projects. So it's also picking up very fast. Passive RFID and active RFID, they tackle different use cases, different scenarios. You use passive RFID in a higher demand, a higher circulation areas. Like I said, in item level or pallet level identification types of applications, passive RFID is the best fit. Active RFID or RTLS, it's excellent for high value asset tracking or people tracking in real time or various other safety related use cases. RTLS is excellent for those types of applications. So in reality, two technologies coexist. They are not competing. They are complementary, and we do deploy solutions by utilizing both technologies together in various use cases, mainly in asset management, asset tracking types of use cases. We utilize passive RFID for low value assets like furniture or linen or towels, things like that. And we utilize active RFID for higher value medical assets or chairs or things like that. So they coexist together.
Okay, so correct me if I'm wrong, but the active RFID, it has a battery in, it has a radio in, antennas in, and it will broadcast its ID actively at a certain interval, like every second or every 5 seconds or faster or slower, depending what you want to achieve. And the distance that the ID will go for will be way higher when compared to the passive RFID tags that are just excited by the external exciters, and then they just reflect their ID in the air with a very, very little amount of power. So with active RFID and passive RFID, it's really similar with how it operates from the location calculation of a tag perspective. Both tags, they broadcast their ID that are being picked up by location sensors, RFID location sensors somewhere, but active tags, they just give us more, like a stronger signal that can be located with more precision if you want to calculate XY coordinates.
Yes, almost. Let me explain in a bit more technical detail about how two technologies differentiate from an architecture perspective. With passive RFID, there are two types of hardware that we typically utilize. One of them is the gate format. So we form a gate, a portal that consists of a passive RFID reader, and then we install various antennas to cover the gate.
So would this be like if you were in a shop and you had these gates by the front of the shop, and then say you've got clothes in the store and they've got those little tags on each item of clothing, and if a shoplifter was to take one of these items of clothing and pass through the gate with this tag on the clothing still, it would set off a trigger alarm?
That is one use case, but passive RFID is not the best fit for security. Passive RFID is an excellent fit for overall identification and inventory management because of a couple of reasons. First of all, passive RFID is very, very sensitive to metal. So if you take one passive RFID tag and if you just cover it in your hand, the hand is blood liquid. So that absorbs all the RF energy coming out of the RFID gates. So there are a lot of ways to cheat the system from a security perspective.
So hopefully no shoplifters are listening to this podcast.
Yeah, we've seen so much. I mean, in our experience, we've seen shopping bags covered with aluminum foil and items in the shopping bag, no alarm. So we've seen that in reality. We've seen in some of our customers that this is happening. People are creative, which is interesting. So the other one is liquids. Liquid is not so much an effect in security, but metal is the main problem. So you cannot install a passive RFID tag directly on metal, or you cannot install passive RFID tag on liquid or even water bottles because they cause a negative effect on the technology. So that's one use case, but the primary use case is on the backstore, so on the inventory side. You create portals, and as a forklift passes through that portal, it doesn't need to stop. It can pick up all of the tags, all of the signals coming out of the tags from those boxes, and it can process everything automatically. That's where passive RFID really differentiates itself from the barcode technology, because traditionally barcodes have been the competing technology to passive RFID. People ask, why should I invest in passive RFID? There's some really good answers, some justifications for that. First of all, with passive RFID, you can process 300-400 tags in 1 second. But with barcode, you can only process one barcode in 2 seconds. So there's like almost 600 to 1 ratio between the speed. So it gives you automation. You're now independent from manual labor. You can just pass through a gate with a forklift, and all of the boxes and all of the items in those boxes can be picked up by the passive RFID gate. That's one big, really important benefit. The other thing is that it doesn't require line of sight. To process a barcode, you need to have line of sight. With passive RFID, you don't need that. So there are similar advantages between both technologies. Coming back to architecture, so we talked about the fixed gates, antennas installed on a fixed RFID reader. The range of that gate will be up to 10 meters. 10 meters might mean the width of the gate, or how far a signal can be received from a tag. Those tags, they don't have any batteries, they don't have any active components in them. They're totally passive. So they just reflect, as you said, they just reflect their ID numbers back to the antennas, and then the readers receive it, and they use the local area network to push all the data to a server. Secondly, we have the handheld terminals. This one is a lot more easier. So we have mobile devices that come with built-in RFID antennas and readers. So you can use that mobile device to count all of the assets in a warehouse, or if that's a asset management project, you can also do that. You can also capture your assets with that handheld scanner. Coming back to active RFID, the architecture is a little bit different, and it really depends on the type of active RFID technology that we utilize. As a company, we are utilizing ultra-wideband more than the others. So the ultra-wideband technology requires a wireless mesh network. So we need to install some anchors and gateways. Installation of those anchors and gateways are relatively simpler and easier than installing a passive RFID gate. So once we deploy those anchors and gateways, we can cover the entire area in real time. But with passive RFID, we're just covering certain read points, mainly gates. So those are some of the really differentiating factors in architecture.
Okay, so with passive RFID, you have the gateways that are called the choke points, right? So you can have multiple rooms, and when assets move between these rooms, divided by choke points, this is being picked up by the system automatically. While with active RFID, you can calculate the absolute location, XY coordinates of your asset in a real
That
time.
is absolutely correct. That is absolutely correct, yes.
Okay. And you also said that the metal and water, it interferes, like it blocks the signal from RFID, which might suggest that it's operating on a lower frequency band. So what frequency does an RFID, both active and passive, operates on?
Okay, so that's a good question. There are different frequencies, so it really depends on the company and the use case. With passive RFID, we typically utilize ultra-high frequency UHF technology. UHF operates in two different frequency sets, and that decision is based on the region. So if we are deploying a project in North America, the allowed frequency is 902 megahertz to 915 megahertz. If we are deploying a project in the EMEA region, Europe, Middle East, and Africa, then the allowed frequency range is between 866 to 868 megahertz. So there are two different frequency ranges. The reason of that is the cell phone frequency. In North America, they're using 868 megahertz for cell phone frequency. That's why they don't allow that specific frequency range in North America, and vice versa in Europe.
Okay, and just a theoretical question. If we were using passive RFID in the area where a different technology is using the same frequency, like a mobile in States, what would have happened? Do we know?
Yes, because the technology is quite smart. There are many built-in features. One of them is called frequency hopping. So the reader continuously scans the frequencies, and it measures the density, the usage in that frequency. If it detects a frequency that is densely occupied, it immediately switches to a different bandwidth. Because we have a 2 megahertz bandwidth available. It's actually 2.5 megahertz available bandwidth. And it continuously switches between those frequencies to find a spot that is less densely occupied. So from an interference perspective, again, in the past 16 years, we haven't had any issues because of interference with other solutions. The same is also true for active RFID, specifically with ultra-wideband. The bandwidth is so large that we have a lot of room to play. So it's typically between 3.5 gigahertz up to 7 gigahertz. So we have a very large bandwidth that we can move within to avoid that kind of disruption. Typically, the main issue is always the Wi-Fi technologies, 2.45 gigahertz. So if you go to a distribution center like 8 million square feet, they have hundreds of existing Wi-Fi access points, and a lot of handheld terminals, a lot of IT devices are utilizing that bandwidth to talk to the servers. So they're really dense environments. In those areas, they don't allow you to utilize 2.45 gigahertz. They want to keep that empty altogether. Even if your technology allows frequency hopping or listen before talk type of technologies, they don't allow you to use 2.45. In those environments, ultra wideband, again, is a very good choice because you can absolutely find an empty or available frequency where you can operate and not disturb overall operations.
Okay, so we very often compare here now ultra-wideband to active RFID. And with ultra-wideband, it's actually quite easy with the interference because it's so low energy that even if it operates in the same area as different technologies, it's normally typically being seen as a noise, and they still can operate together. How does it work when compared to the active RFID? Is it also as low energy technology as ultra-wideband? Because you said the RFID is very narrow band when it comes to the channels used. It's like 2.5 megahertz versus 500 megahertz on ultra-wideband, right? So is it correct that both passive and active RFID, do they use 2.5 megahertz band?
No, so active RFID, they have different frequencies. 2.45 gigahertz is one frequency. 433 megahertz is one other active RFID frequency. I've seen active RFID technologies based on 868 megahertz. That frequency selection is purely up to the technology provider, and each technology provider selects their own allowed frequency ranges. With passive RFID, it's regulated. So there are international organizations that are regulating it, like ISO. There are protocols, international protocols with passive RFID, such as ISO 18006C. This means that you have to use a certain frequency bandwidth, and you have to use specific frequencies. So there are international regulations. Active RFID, nothing like that. Companies, they just pick their own technologies and they can use different things. So the result is with passive RFID, you can use different hardware from different vendors and you can create one technology, one solution. You have that flexibility. With active RFID, you have to use the same tag, the same reader, the same hardware, and the same software from one single provider. It doesn't give you that level of flexibility. That's also one of the main differences between these two technologies. But again, it all depends on use case, because active RFID can never be used in a passive RFID use case and vice versa. So we first look at the use case. We first understand the customer requirement, and that's how the technology, the right technology type is selected.
Okay. And what is the range of the active versus passive RFID?
With active, it's real time. So you can receive signals from even 100 meters away. So a tag is here. I have the receiver 100 meters away from me. I can still talk to that tag. That's the biggest effect. With passive, it's maximum 10 meters.
Okay, that's quite a difference,
Yeah.
I would say. And when it comes to the ranging techniques with the active RFID, what do we use? How do we calculate the distance between the location sensor and the active RFID tag?
Number of different algorithms and number of different technologies are out there. A lot of the companies utilize RSSI, but some other use triangulation. When triangulation is used, we have algorithms such as two-way ranging or time difference of arrival, or time of flight, or angle of arrival. So there are 4 or 5 different location techniques that you can utilize. With passive RFID, it's a lot more simpler. Again, you just, that comes with the reader. So the location technique is, it doesn't even locate the tag. It doesn't give you X and Y. It just identifies the tag. So with passive RFID, there is no location, and all that middleware, all that firmware is built in to the device. So the hardware provider ships the product that comes with that firmware already installed in it.
Okay, interesting. So just to recap, passive RFID, there is no absolute location. It's just purely relative between a tag and the gate. So you can just know if the tag is nearby or not. With active RFID, you can use either RSSI distance-based location with multilateration, trilateration technique to calculate the absolute location of a tag, or you can use angle of arrival and triangulation to locate the tag even with more accuracy. It's more complex than RSSI and multilateration, but it gives us theoretically better results. Okay, amazing. So when it comes to scalability, now let's move to scalability. How many tags can we have with active and passive RFID being located simultaneously?
So with passive RFID, you can process up to 300 to 400 tags per second. Theoretically, on paper, there are companies that claim that they can even process 1,000 tags per second. But in our testing, we just haven't seen that. So that's why when we talk to a customer or a partner, we typically commit to 300 or 400 tags per second. Still amazing. Still, it's very fast.
I mean, yeah, still quite a lot of tags per second, right? I mean,
yeah.
What's the what's like the largest deployment of tags that you guys have done?
11 million tags in one project.
Wow.
Yeah. Yeah, we can talk about that project as a use case if you're interested towards the end. I can explain. I can tell you more about that project. It's very unique.
Absolutely.
Sure. So, and also for the active, the number depends really on the architecture. So again, that's one important information we need to ask to our customer in the beginning in our requirements analysis. We need to understand what can be the maximum tag population in one operational area. One operational area means our access points, coverage area. So it can be like 100 or 200 tags. That will be the maximum. So we can only, so imagine it's like a 50 square meter area. In that 50 square meter area, the maximum number at any given time could be 100 or 200 tags. If there's a use case that requires more, then it's also possible. We just need to adapt our technology, adapt the architecture. So the maximum deployment we've done so far with active RFID in a single building, it was 10,000 tags. It was a massive deployment, 10,000 tags in a single building.
And is that how you refer to your RFID access points? So for Wi-Fi, we obviously call these access points. In ultra wideband, they're sometimes called anchors, but in the RFID world, you also refer to these as APs.
We also call them anchors and gateways in active RFID, and in passive RFID they're just readers and antennas.
Perfect, thanks for that. Yeah, it's funny when we switch, but talking between Wi-Fi, ultra wideband, RFID, and then it's like when we speak to like the Solona guys around private LTE as well. So very similar sort of devices, but all called slightly different things.
Mm-hmm.
So we can call them tags, location sensors, right? Location
APs, anchors, gateways.
So anchors, gateways, it's a proprietary for technology. It's not.
That is correct. That is correct. Absolutely.
Okay, so still, since we've started discussing components, would you like to give us a more insight into what is required for both active and passive RFID to operate?
Okay, so for passive RFID, if we're deploying a fixed gate like a portal, we need to deploy fixed RFID readers. We need to deploy antennas, and the quantity of antennas per reader might change. It can be 1 antenna per reader or 2 antennas per reader or maximum 4 antennas per reader. With 4 antennas and 1 reader, we create a gate and we cover that gate. So that will be the infrastructure, the components that goes to the gate. And then we have handheld scanners, which is optional. But they're really valuable in a project. It gives you flexibility. We have RFID printers to print and encode the tags. So that's one other essential component. And then we have some accessories, like we can install sensors, motion sensors within the reading area. The motion sensors detect motion within the gate coverage area, and then it would activate the gate. When there is no motion, we can put the gate in standby mode and not scan anything. These are some optional features that we've built for our customers. So those would be the components. To summarize, it's readers, antennas, handheld scanners, and RFID printers. And optionally, we can also provide I/O support, motion sensors or alarms or buzzers, things like that. So those will be accessories.
Okay, just a quick question here. So we have readers, antennas, gateways. So can I say that the gateway is the same in the other books, how it's been covered? It's been called the exciters or interrogators, and you call it gateways. Is it the same?
Interrogators are one other common word, yes. So we either call them a gate or an interrogator or just readers and antennas.
Okay, so it's just multiple different names for the same
Absolutely,
thing.
Yeah.
Great, just so it's not too confusing. We have 3 names for the same stuff. How about the active RFID?
For active RFID, it's a lot more simpler. So we have the tags, then we have anchors, and we have gateways. Those will be the hardware components.
Sounds awfully unlike the ultra wideband.
Yeah, very similar. Ultra wideband for us is also active RFID. We call ultra wideband active RFID as well. So it's similar principles.
Okay, really? So you So you use the term interchangeably, like ultra wideband and active RFID.
Absolutely, yeah.
Okay, that's very interesting. So when you think about it, ultra wideband is active, and it is
It
RF.
is, yeah. It
Yeah,
is RFID, yeah.
yeah. Okay, so active RFID, like typically many years ago, before the ultra wideband was being used for RTLS application,
Mhm.
was it using similar frequency ranges to ultra wideband, same principles, like a very short pulse, a very short chirp from a tag that is being located by the anchor, picked up by the anchor with a very good accuracy using a time of flight or TDOA or
Yeah.
TOA. So is it very similar between the traditional RFID and ultra wideband?
It is very similar, but after ultra wideband, our accuracies have improved significantly. So prior to ultra wideband, our active RFID solutions were based on 2.45 gigahertz chipsets. We needed more infrastructure, and still with more infrastructure, we were able to provide maybe a maximum 5 meters of location accuracy. But after ultra wideband, the required infrastructure was reduced significantly, and our accuracies has gone down 1 meter. So we are now at sub 1 meter. There are some use cases where we're offering 30, 40 centimeters, which is quite unique. And we're able to do that very, very consistently. That's also one important factor. Again, with 2.45, the accuracy was not consistent. You're looking at a map, tags, they jump all the time. So you had to apply a lot of filtering, and you have to do a lot of fine tuning. I mean, it was very challenging, but ultra wideband really improved a lot of things from a technical perspective.
And Wi-Fi guys, if you look at the RF spectrum with a, say, like a sidekick, and you're looking on the 2.4 gigahertz band, you'll see a lot of passive infrared. If you do a shopping center, I usually would see a lot of passive infrared, usually around channel 9 on 2.4 gigahertz, a very small spike. So yeah, that's where if you're a Wi-Fi guy and you're looking at layer 1 RF spectrum, that's where you probably would have seen some of these PIR sensors before.
And that's the very narrow 2.5 megahertz wide channel.
Mm-hmm.
Being used by the passive RFID. Okay, so what has changed between the traditional active RFID and ultra wideband when it comes to improvement in accuracy? Is it a different frequency, just a higher frequencies used, or a wider frequencies used?
I think the measurements are now a lot more precise. The distance measurements are a lot more precise. Chipset companies like Decawave invented different technologies. I think Decawave today is the leading ultra wideband chip provider, and their technology is it really works well. So that's the main difference. And I think it's all about measuring the distance and calculating the distance very precisely. That gives us the raw data. The next thing is our location engine. So there are two very, very important factors in location. One of them is getting good measurements from the chip level. Second is calculating the location based on the raw data that you receive. So these two go hand in hand, and they're very, very important. So to answer your question, what's changed? It's the chipset and Decawave's chipset that's really changed the ultra wideband RTLS industry.
And crunching the numbers sometimes can be one of the most difficult parts of a RTLS system, and usually sometimes requires some serious server power to be able to do this data crunching. Do you guys have your own platform? Like, is it cloud-based? Do you need a physical appliance? Like, can you give us some background about that?
Absolutely, and that's very, very valuable for a customer. That's where the main value is out of the entire investment, is being able to analyze big data. Specifically, if we're talking about active RFID / ultra wideband deployments, a typical system generates billions of data. Or maybe even tens of billions of data, and they're all location based. They're historical data. And you can analyze, when you analyze that data, you can do unimaginable things. Some of the things that we're working on, we are investing heavily on AI. And so we are combining AI with ultra wideband. After 6 months of deployment, after 6 months of data collection, our system utilizes AI algorithms to learn and to predict for the customers. In a supply chain environment, for example, we are working with some large e-commerce companies around the world. We collect their forklift utilization and we calculate how much a forklift is utilized, where, for how long, by whom. When you have this level of data for the past 6 or 9 months, you're able to predict the demand for the next 6 months by looking at that data. So data analysis is something really important. We do a lot of route optimization for order pickers or for forklifts, give them the shortest path to reach an area based on past learnings. And we do similar stuff based on AI. But even without AI, you can do a lot of stuff with big data. You can crunch the numbers and you can play with the consumption, utilization of your assets, utilization of your workforce, your employees, accidents, safety issues. All of those data can be now measured by utilizing big data analytics platforms.
And how long can you,
driven by our solution.
Say if I wanted to go back and look at that data, you mentioned 6 and 9 months previously. How long can you retain that data for? How long, what's your history timelines? Can you go back 1 year, 18 months, 2 years?
No limits. It really depends on the customer and their IT infrastructure. So they can keep the data as long as they wish. We have no restrictions. There are some regulatory things to watch out for, like GDPR in Europe. You can't keep personal data for more than X number of months, things like that. So there's also the regulation aspect. If you're storing employee information, then you can only store it for a certain period of time. But for assets or for other things, there is no time limit.
Wow. So is that data stored like locally on a device, or do you have a cloud system that it goes back to?
We are flexible. It really also depends on the IT security policies of our customers, because some of our customers are governments or very large Fortune 500 companies. So their IT security policies are sometimes tight. They don't allow cloud hosting. For example, it needs to be on-prem. So we support both cloud or on-prem deployments. And when we talk about a cloud deployment, we have options like private cloud or public cloud or hosting it on the customer's cloud. So there's a very flexible business model there.
And if it's going to be in Europe or the USA, things like that. Well, that's amazing. That's great that you give your customers the option to do that either on-prem or utilizing the cloud.
So that's your application, like your location system that can sit in the cloud. So that's the end way for the user to see the results of the data that you crunched through. But the data crunching, do you do it also in the cloud, or do you do it like, where do you have the location engine located? Is it in the same platform as location system / application, or is it somewhere else? Does it live locally maybe?
It can be stored locally, but it can also be hosted on the cloud. We can store the location engine on the cloud.
Okay, so if you have like 10 million tags, all of them, they are, providing the system with their IDs. Will you have all the information from all the tags, from all the sensors, all the gates being sent over to the cloud for data crunching? Is it not excessive when it comes to the amount of the information and the cost effectiveness of a data being sent to and from the cloud?
So that 10 million, 11 million project was based on passive RFID. So there is no location. We just identifying by getting the data. And you're right. Even with that approach, the amount of data is massive. So there was a really complex IT infrastructure, IT architecture behind that project. We set up regional data centers. Those regional data centers collected information from regional devices, and the regional data centers are then connected to 2 different distribution centers in the country. And that's where the data is consolidated for backup purposes. That was the IT background of that project. In active RFID / ultra-wideband, the largest deployment is probably like our largest deployment is about 35,000 tags. And again, the IT infrastructure for that project is quite massive because of receiving all that amount of data nationally and being able to process them. You need to have a distributed network. And that distributed network needs to be managed in a really complex way.
Yeah, I guess it must be quite complicated. So it is a server-based positioning with your active RFID/ultra wideband, and the server can live in the cloud because
Correct.
you never have too many tags for it to be overwhelmed by the amount of the information coming to and from the cloud. Amazing. How about the cost of the systems, of the active versus passive systems?
So cost is a relative matter because it really changes based on the project type and the project complexity. Maybe we can talk about unit costs and do a comparison there. The key differentiator is always the cost of tag. So with passive RFID, the unit average cost is going to be 10 cents or less, and it will change based on the tag type that we utilize. With RTLS, active RFID/ultra wideband, the tag costs will be around $50 to $100 per unit. So that's where the biggest change will come from. From a software and infrastructure perspective, they're priced similarly. There isn't a big gap in between.
Okay, so when it comes to the design, we appreciate that tax is the main differentiator when it comes to the price. But let's forget about the passive RFID now, because it won't be too relevant when compared to the active technologies like active RFID and ultra wideband. So passive is easy. We just install it wherever we need to have a choke point in. If it's a massive warehouse, we need to just say if it comes in or out, we'll have one gateway, and that's simple, right? And then multiple tags, and life is easy. With active solutions, what is the design difference when it comes to the density of anchors for RFID versus ultra wideband? Which is more expensive and more demanding design-wise?
Design-wise, I think the customer requirement is also very important here. The accuracy is one important factor. If a customer requires 1 meter or less accuracy, then we only have ultra wideband as the technology option. But if a customer can live with a 10 meter or 15 meter location accuracy, then we have options like BLE, for example. BLE is one option, or traditional 2.45 gigahertz based active RFID technologies are options. Again, the biggest difference will come from cost of tags, even in active RFID. If you use BLE technology, for example, unit tag costs will be $10, $15, $20, again, based on the quantity and the tag type. And with ultra wideband, it's going to be at least double the cost. From an infrastructure perspective, the answer depends on the customer's overall coverage requirement. So if they are okay with a zone level tracking, for example, they have a warehouse, they want to divide their warehouse into 10 different zones, and they just want to know when an item leaves and enters a specific zone. We just need to deploy hardware enough to cover zone entrance and zone exit. But if they want to track a forklift in real time, and if they want to watch a platform, a software, a map, an indoor map, seeing how the forklift moves, then they need to have a real-time coverage. Very similar to a Wi-Fi coverage. They need to have enough coverage in the warehouse so that they can track real-time movement. So that's one important criteria to determine the required infrastructure quantities.
Okay, so let's say that we have the same requirement for both RFID and ultra wideband. We are fine with 3 meters accuracy, and we want to cover an entire warehouse. Which one is more expensive?
Then ultra wideband is probably going to be more expensive.
Okay, and when it comes to sheer numbers of anchors, is it going to be similar?
Sheer number of anchors, it will probably be similar. Yes, it will be similar. But yeah, 3 meters of accuracy with any other technology than ultra wideband, again, is challenging, because I'm thinking about BLE, I'm thinking about Wi-Fi systems. Their accuracies, you have to deploy a lot more infrastructure to get that level of accuracy, even with Wi-Fi. We've seen so many Wi-Fi solutions out there. They need to deploy exciters, additional sensors to get higher accuracy, higher resolution. With ultra-wideband, so I'm switching my answer. It's definitely with ultra-wideband, you'll need less infrastructure to get that kind of accuracy.
No, it's fine. It's interesting. It's like, all the answers that I'm trying to get about the different technologies, you go back to ultra-wideband, but you're not the first person doing it. We are very simple. If you want your RTLS to work flawlessly, then probably ultra-wideband is pretty much always the answer, especially in more challenging environments.
And I'd say for now, yeah. As I say, for now, obviously ultra wideband is probably more expensive than the RFID. That's because RFID has been around for longer, so there's more mass production of it, and the parts are more readily available, and there's more people making these tags. Whereas ultra wideband, yes, it's been around for a while, but it's not being used as much as RFID. So we may see a shift in the next following few years with so many mobile phones now having ultra wideband antennas inside of it, and there'll be more people other than Decawave. I know there are more people than Decawave making ultra-wideband chips and tags, but in the future there'll be even more companies building these. So, at the moment, the ratio, because of there's so much more for RFID than there is ultra-wideband, but who knows, in the next few years, ultra-wideband may become just as cost-effective as RFID.
Active RFID, I think so. Right now NXP has announced that they now built an ultra-wideband chipset. So apart from Decawave, there will now be NXP offering that chipset. Apple has already built it in their phones. I know that some of the other smartphone manufacturers are almost done with building ultra-wideband.
Xiaomi is also done, I think, So this is top 3, I believe. There is Huawei in top 5 as well. I don't think they have ultra-wideband yet, but I can't see them lagging behind for too long.
Yeah, absolutely. So there will be massive market adoption. Currently, all the deployments are B2B, but I'm expecting a lot of B2C types of applications with ultra-wideband in the upcoming years as well, because of this availability.
That would be absolutely smashing. Okay, so I think that has covered the theory of active versus passive, about the challenges, some basics of the design. So now I'm dying to hear more about your big deployment of the passive RFID.
Okay.
So
11 million tags.
Yeah, that's crazy, isn't it? That's madness.
Right. So that project is a massive project, a very complex project. The use case is electronic toll collection. And it's a nationwide project located in Turkey. The project was first initiated back in 2013, and it took us about 4 years to deploy it nationwide. And still, we're expanding that project. Essentially, the system is deployed all over the country at more than 800 locations. When I say location, I mean a specific lane where vehicles pass. And in all those lanes, we've deployed passive RFID readers and antennas. But that was not the only technology. We've also deployed ANPR cameras, automatic number plate recognition cameras, to associate a tag ID with the license plate. So the RFID reader scans the RFID tag, captures the identification number. The camera scans the license plate and converts it to text. And we have a handshake. We compare the RFID tag with the license plate. We check if the right vehicle is equipped with the right tag. And then we also classify the vehicle. What type of a vehicle is this? Is this a SUV, a large trailer with a truck, or a motorcycle, or a normal vehicle? So we have underground systems that electronically classify a vehicle. So a vehicle passes the gate at 100 kilometers per hour, and that just happens spontaneously, instantly. So that's where you need all that computing power. You're scanning the tag, you're scanning the license plate, you're classifying the vehicle, you're comparing everything together. You're linking this information with the bank account, because also that vehicle is charged immediately as they're passing through that gate. So that's the lane structure. So on all of those 800 plus lanes in all over the country, we've deployed the same system. And 11 million vehicles in the country today, they have their own passive RFID tags on their windshields. Those tags are smart tags, so they break on removal, for example. If someone tries to take out the tag from the windshield, the tag destroys itself immediately, physically. You cannot take one tag from a windshield and put it on another vehicle, for example. So we have the breakaway removal feature. And then we have built a massive IT infrastructure to support all these data connection points. There is a lane computer at each lane. So we have 800 lane computers. We call them the lane controllers. The lane controllers collect the data from each lane, and those lane controllers, probably 20 to 25 per toll gate, they're connected to a server in the toll gate. And that toll gate is then connected to a regional processing center. And that regional processing center is connected to two main distribution centers. And then banks call data from that system. And probably all of the major banks in the country are using this system. And then there's the selling, there's the retail portion. So when you want to sell a tag to a vehicle, we've connected all the gas stations and post offices. And that's like thousands of locations, tens of thousands of locations in the country where they can identify a tag and sell the tag to a driver. And then immediately after that point of sale, the tag is linked to a vehicle, to a bank account.
Nice.
And
So what is
we
the
can
benefit
start
for
receiving.
the end user? Like if I live in Turkey and I don't want to pay manually for the tolls or pay for the petrol, I can buy the tag and just use services that support your service to automatically charge me for going through a tunnel in the motorway or for refueling my car without me having to even open the door or window from my car. Is that the application?
Yes, but you have no option in Turkey. You have to have this system to use the motorways. So that's, again, it's regulated by the government. So you need to have a tag on your windshield if you want to use the freeways, the highways.
Oh, wow. And how long do the batteries last in these RFID tags?
They have no
There's no battery.
Wow.
It's passive, no battery.
So yeah, they just get put in there and that's it. They're good to go forever.
Yeah, absolutely.
Mm-hmm.
So this project is considered the world's largest deployment of this type in a tollway. So there is no larger one than this. It's a massive deployment.
Yeah,
Well
sounds
done,
like
guys.
it. Congrats.
Yeah. Thanks.
Sounds overwhelming just to think about the numbers. How about the reliability?
I mean, its reliability has to be 99+% because it's collecting money at the end of the day. So it's also being monitored, and so it's very reliable. I mean, we haven't had any issues.
Wow. Any challenges like when it comes to the locating of the tags and the distance and the speed of the cars, or the, I don't know, like during the traffic hours? Do you have any
the system was designed based on all these challenges in the first place. It took a lot of time to reach the right design. But I mean, the type of hardware that's installed at those gates, they're all designed to support these types of fast, high-speed deployments. So we haven't had any issues. I mean, we've tested even vehicles passing at 200 kilometers per hour. I mean, the system still reads the tag, and it can even write data back on the tag.
So you're going to start putting them on F1 cars now as well?
We can. I mean, we've rented a Ferrari and we've rented a racetrack to do some tests.
Mm-hmm.
So, with the Ferrari, we've even reached 240 kilometers per hour, and we had 100% success rate identifying that vehicle at that kind of speed.
Mad. What data do you feed back to the tag when the vehicle passes?
It depends on the use case. I mean, so you have the option of writing the data back to the tag, or you use the tag just to identify a vehicle. That really depends on the customer's requirements. Some governments in different parts of the world, they might want to store offline credit information on the memory of the tag. That's one option. If you're doing that, you have to write data back to the tag. But if you want to just identify the tag and do everything online, then that's another decision. I think the second option is a lot more simpler and faster than the first one. But really, it really depends on the government regulations and the requirements.
Of course. And when it comes to the equipment used, is this the Litum equipment? Like if if we have a government that would like to use your products, your expertise, your experience, what do they buy? Who do they go to? How does it work? Do you produce the equipment, or do you use third-party components?
For passive RFID, we do not manufacture the hardware. We use readily made, available internationally types of devices, but we build the software. But more importantly, we focus on the systems design and the engineering part of it. With ultra widebands, we manufacture A to Z everything, all the tags, all the anchors, gateways, or everything is manufactured in-house.
Nice. Okay. So do you have a global reach when it comes to access to the parts, components required to make passive or active RFID to work? Do you have any constraints?
No constraints. I mean, we have a supply chain division in-house. So we buy components all over the world, and we bring those components to the country where our manufacturing site is. And we assemble and manufacturing everything here in Turkey. And then we distribute them globally. So we have no issues. And we have a very talented team looking after that process.
Nice. So based on the conversation, RFID is not dead, is it?
It's not dead. It will not die. It will not die. It's actually becoming a commodity. Passive RFID is everywhere in retail stores. Retail is one massive adapter of passive RFID technology. We've worked with governments on document management types of use cases. Tracking intelligence documents, for example, was one use case we deployed. Asset management applications, warehouse automation types of solutions, they're all very good fit for passive RFID. So I don't think passive RFID will die. It will even become bigger. It will become the de facto standard after barcode. So it will be the second generation after the barcode technology. And active RFID or ultra wideband will always complement. So it will have a different track, and sometimes their paths might cross, but they will go in parallel.
Sometimes you don't need this absolute expensive accuracy, right? You're just good with few choke points, and that's it. That's interesting, actually, because we've heard quite a lot of opinions about, you don't need passive RFID, it's dead. Ultra wideband is all it matters today. So that's great. How about if you wanted to test it, to have your products tested, like in our lab environment, to learn more about what's available? Do you have some tester kits that you would be able to provide your potential customers with? To, I don't know, send over like a small package so we can unpack it, follow some simple instructions, and then have passive RFID running in our lab to see how it works, what data we can have from your location systems, how it looks like, what reporting do we have available? Do you have that?
Yes, absolutely. We have demo kits for both technologies, both passive RFID and active RFID. So that's how we work with our channel partners in the first place. So we have them here for training, and once their training is over, we send them back with a demo kit so that they can continuously test the system, run some use cases, and understand the technology. So it's really beneficial. So we do have demo kits for both options.
Interesting. So if, let's say, we wanted to become your channel partner, how difficult is it?
So it's not difficult. We just need to understand if there's a good fit between both companies. First, we have a well-defined process to assign channel partners. We first, have an initial meeting, an online meeting, to understand their potential projects for the next 18 months and where our technology might be a good fit. Once we understand that there's a fit between both companies, they need to sign an NDA, and we have a cooperation agreement that we need to sign. And then we have the partner come over for their technical and sales trainings. We spent 2 or 3 days together before COVID. Now everything is online, but hopefully, we can resume those meetings, those training sessions. And when they have their trainings, they go back with the kit, they install it, and they just use it on their own. And our partnership begins this way. After we start the partnership, our partners register their projects with us, and they become an organic extension of our company. So we work like the same company. We help them on all aspects of a cycle with demos or meetings with the customer, sales meetings or technical meetings. We design systems together. So that's basically how we work with our 50 partners in all over the world.
Very, very nice and comprehensive. And you said design systems. how do you design systems? Do you have some tools to design for the RFID?
We do have some in-house tools that we use to design a system. First thing is we need to really understand the customer requirements. So we have pre-made questionnaires for each different type of solution. We have our partners fill out the answers for these questions. Those answers allow us to understand what the requirement is all about. And then we collect data like pictures or videos and also drawings of a site. And then we use our tools to understand what kind of infrastructure is needed to cover that area. And basically, that's the process we apply in order to understand use case and define what's needed.
Absolutely smashing. Özgür, thank you very much for sharing all this information, because we haven't heard such refreshing things about RFID in a long time. So it's really nice to know personally all about that stuff. I hope that community will also be thankful for knowing all of that interesting stuff.
My pleasure.
Thank you very much, Özgür. How do people reach out to you or find you if they want to find out some more information, or arrange like a proof of concept or see some demos? How can people get in touch?
Sure. So they can access our website, litumiot.com or litum.com, or they can just send an email to info@litum.com. So those are some easy tools to reach us.
Are you available on Twitter or LinkedIn for easy communication?
Yes, I am available on LinkedIn as well. So they can just type my first name and last name, and they can find my profile on LinkedIn.
Perfect. So we will make sure to tag you on LinkedIn. How about the Litum? Do the company have a profile as well?
Yes, Litum has a profile everywhere in all of the social media accounts: Instagram, Twitter, Facebook, and LinkedIn.
Mm-hmm.
Perfect. So we will tag you on all the platforms that we live
Excellent.
on as well. And any more questions or things that you wanted to talk about?
I think this was a very good summary. So thanks for having me on this session, and we'll be in touch.
Absolute pleasure. We will have another episode with guys from Litum with Özgür. We are looking forward to it. We will cover some more ground with active RFID/ultra-wideband in January 2021.
Mm-hmm.
Yep.
Well, thank you very much, and we will see you then.
All right. Thank you. Bye-bye.
Thanks.